Okay, class, we're back now, and what we're talking about now are the meninges, the brain meninges. Now, let's think about what we did before. We did it for the spinal cord. We said we had a dura mater, right, an arachnoid, and then we had a pia mater. So we did it for the spinal cord. It's the same for the brain, but it's a little more involved. So just let's look at it, but it's really the same. So let's start with what we already have. All right. This would be the skull. Okay, so if you think about your scalp, this is the skin on your scalp. The skin is on top of the periosteum of the bone, of your skull. Then the bone itself, the skull. Then inside that, here goes the dura mater, the arachnoid, and the pia. Just like we had with that. And the pia mater is adhered directly to the brain, just like it was in the spinal cord. So up to now, everything is really the same. Okay. The difference is this. When it comes to the dura mater right here in this mid part of the brain. Now let me show you what I'm talking about when I say the mid part. Right here, this is an anterior. See how that goes in right there? This is your longitudinal fissure in the brain we'll talk about. But anyway, right here, this is what's going to happen. The dura mater is going to split somewhat. Let's go to this picture. The dura mater, so one part of the dura mater, but only right there in that center, one part of the dura mater is going to split in two parts. This would be kind of the periosteal dura mater, there. That would be right there stuck to the inside of the skull. But then the dura mater here is going to split. That's the dura mater there, and that's the meningeal dura mater. You see, it splits right here. One part stays there, so it's kind of divided, but right only in that area there, really. Okay. So they try to show here the dura mater, the meningeal, the periosteal part, and the meningeal part. They really are together, except kind of in certain spots. They really are both fused together. See, you didn't have this in the spinal cord. It was just one solid sheet. All right. So right here, what's going to happen, it's going to split right there, right in that front view of the brain, right there. Would have been right there after meninges. Okay, now I'm going to come back again. That split, though, not only makes this, and this right here is going to be the superior sagittal sinus. It's a big vein. I'll talk about that in a moment. But right in here is blood. Where that thing splits, this is a big blood vessel. So, but the rim of the blood vessel is actually blood vessel tissue. So though it's split, it's still not the epithelial layer of the blood vessel. It's split, and then the epithelial layer of the blood vessel, this big vein, is stuck to it. But anyway, we'll come to it. But I want you to know how it splits and goes down here. Now, what that is that the dura mater actually goes between the two hemispheres of the brain. That forms, so it's going to go straight down here, just like this here, and that forms this right here. So here's the dura. Here's where it split and went down right there in this drawing. So this right here is called the falx cerebri. The falx cerebri. Let's go back up here. See right there, the falx cerebri, and it goes into the longitudinal fissure, this here, and it separates the two hemispheres of the brain right there, the falx cerebri. Now, in addition to that, it splits in another area. Okay, I'm going to go to a side view. Follow with me. So here would be the falx cerebri. Here it's going to split again and cover the cerebellum. So in the floor of the skull, the cerebellum would be down here. It will cover, it's like a tent over the cerebellum. And that's what they call the tentorium cerebelli. I'm going to come here. See, here's your cerebellum right there. So this right here, right there, is the tent over the cerebellum. And that would be the tentori cerebellum. Tentorium cerebellum. Also called cerebelli. cerebelli. Then I want to do one other thing. I want you to notice now, if I can do it, do they have it here? No, they can't see it on that view. Okay, so I'm going to come here. I'm going to come back to this view here. The cerebellum itself is split into two hemispheres, we'll say. And between the two hemispheres of the cerebellum is the falx cerebelli. Now, I don't think we have another. Your book doesn't, okay. But anyway, they talk about it here. The falx cerebelli runs along the vermis of the cerebellum. See, right here, this right here is the vermis of the cerebellum, worm-like area. So other words, let's just go back and see what I'm saying. I'm saying that, number one, as a review, that the meninges are pretty much the same in many aspects as that you saw in the spinal cord. There's many aspects as to that you saw in the spinal cord. When we did the spinal cord, we talked about those meninges, and we said that really is not that much difference. Let's see if I can find something here. See, here was the dura mater there, and trying to see if I see that there from some previous stuff. But anyway, it was really not that much different than you had there. Okay, we had a dura mater, we had a pia mater, and so forth like that we talked about within that. Here was this cross section, and we said that we had a dura mater, epidural space, and all that stuff like that. Okay, so when I came back to the brain, let's go back to the brain again. I'm saying it's not really a whole lot different as far as in most locations. Dura mater, arachnoid, pia mater. All right. But when we get down here, the dura mater splits right there. The dura mater splits. Okay. And when it splits, it forms those falx and that tentorium. Now, also don't forget that in many ways, it's going to also be very similar in this particular aspect. Okay. For example, right here, let's talk about it. So in the brain, let's go back. You really don't have a epidural space in the brain. Now let's add some material. Why? Because the dura mater is stuck directly to the inside of the skull cap. So like in the spinal cord, you had an epidural space. Remember, that's where you do the epidural anesthesia, because the dura is not stuck to the inside of the bone in the vertebrae. We said it again. What am I saying? It's not stuck to the inside of the bone in the vertebrae. But when I showed you a vertebrae, it's not stuck to this. So there was an epidural space. There was an epidural space that you had there. And remember, we talked about putting that needle there in the epidural space, dura mater, arachnoid, but you do have a subdural space in the brain. That's how you can get a subdural hematoma. Sometimes a subdural hematoma after, let's say, a car accident. So you do have a subdural, but you don't have an epidural. Now, the arachnoid is very much the same. And remember, the subarachnoid space had those spider web looking things. And that's where the cerebrospinal fluid floated. And that is also true in the brain area, this subarachnoid space. Spinal fluid is no different than it is with the spinal cord. As a matter of fact, that fluid floats around the brain in that space, and we'll come to it because we're going to do CSF in the next one, and also down into the spinal cord in that same area. So that's different. And also the same is that the pia mater is stuck directly to the brain. The pia mater is stuck directly to the brain, just like it was stuck directly to the spinal cord. So there's only a few differences, and with that, it is mainly with the dura mater splitting in two pieces to give this superior sagittal sinus and the falx cerebri between the hemispheres of the cerebrum and the falx cerebelli between these two lobes here on the cerebellum, and then the covering over the cerebellum separating it from the cerebrum. the tent called the tentorium cerebelli, right there, tentorial cerebelli. All right. So that's where that's the main differences that you would see. All right. So I'm going to close this, and this would be my brain meninges discussion. Okay. Thank you.